The sun's shining, birds are singing, and all feels right in the world.
Until the season changes, and suddenly you lose your motivation to get out of bed. In fact, 1 in 5 people experience some form of depression, no matter the season or time of year.
At the American Psychiatric Association Foundation, our vision is to build a mentally healthy nation for all, because we want you to live your best life and be your best you all year round.
Please visit mentallyhealthynation.org to learn more.
You're listening to an Airwave Media Podcast.
Welcome to Unbiased Science, where we bring scientific method to the madness. I'm your host and public health scientist, Dr. Jess Steier. And holy moly, we are back for season 5 of the podcast. I actually can't really believe that that's a thing. You know, I joke, but it's so true that I still find it hard to believe that there are folks who listen to this outside of my mother and her friend group. So thank you to those who are listening right now. Thank you so much for your ongoing support. If you're looking at the screen right now, you probably see that there's another human being on the screen, Dr. Sarah Scheinman, who I'm going to introduce in just one moment. But I am going to just keep awkwardly talking just briefly before we jump into a conversation with Sarah. So just a couple of really quick updates. Summer's been wild on a personal note, on a professional note. Things have been so busy. It really has not felt like the summer. It certainly has not been a summer break. That's just not a thing. I'm really excited to share a little bit more about stuff that I'm doing with my data science consultancy, really leaning into some of my health policy evaluation expertise. I'm working on some awesome policy evaluations. And interestingly, a lot of the focus of my work right now is on mental health interventions, mental health programs, and in particular, those targeting children. So can't wait to share more about that. Also doing some really cool stuff focusing on rural populations, which is something that's really important to me. Those are often hard to reach populations. There are some access to care issues. So anyway, I've been busy. Also, as you may or may not know, I've been running the pod and the pod social media pages solo since February, which has been, you know, it's bittersweet. It's fun to really lean into my public health expertise. As you all know, or I think you know, I'm a public health generalist, right? My training is in the critical appraisal of evidence. I'm really good at assessing trends and data. But that being said, I don't have deep subject matter expertise in certain biological sciences, chemistry, stuff like that, which is why I'm super excited that this gem of a human over here, Dr. Sarah Scheinman, sent me an email. I guess it was a couple of months ago at this point. And I am all about that chutzpah. You know, I love that Sarah reached out and basically sent a note saying, we'll talk about the incredible research that she's doing and her expertise. But she mentioned that she's really passionate about science communication. And so we got on some calls, and I got to tell you, I feel like I've known Sarah for years. I have fallen in love with her chutzpah, like I said, just her awesome personality and the way that she's able to balance technical expertise in science as well as that human element, you know, and really making it accessible for folks. So you're going to be seeing a lot and hearing a lot from Sarah on the podcast, which I'm really excited about. Sarah is probably mortified right now. It's like, I'm talking about you, Sarah, and you're in the room. Everything's okay, right?
Everything is fine.
All right, so Sarah, just to mortify you, can I use that as a verb? I don't know. A little bit further.
Yeah, that's grammatically correct.
That's grammatically correct, right? I'm going to read.
You're flattering me.
Yes.
but also keep going.
I'm going to read Sarah's bio, and then we're going to chat, and we're going to chat about a topic in which Sarah has some real deep subject matter expertise, a topic that I get asked about quite a bit. And the topic today is Alzheimer's and even more generally cognitive decline. Obviously, that's something that we all hope to avoid. There's lots swirling on social media. I see constantly these claims about things we could be doing or should be doing to prevent it or treat it. Some of it has some seedlings and grains of truth. Some of it is just not accurate at all. So we're going to hear from an expert today. So without further ado, let me introduce Dr. Sarah Scheinman. Hang on, I'm pulling up her bio here. Here we go. All right. Dr. Sarah Scheinman is a Chicago-based neurobiologist with expertise in basic science, preclinical, and translational biomedical research. Her primary focus is on the molecular mechanisms of aging and neurodegenerative diseases, but she also has subject matter expertise in cell biology, genetics, epigenetics, and psychology. She received her PhD in neuroscience from the University of Illinois College of Medicine and is currently, no big deal, an NIH-funded research fellow at Northwestern University. Sarah's passionate about science education and serves as an adjunct faculty member at the Erickson Institute in Chicago. She believes that anyone, anywhere can understand science and think scientifically and seeks to alleviate the fear and mistrust that prevents widespread scientific literacy and accessibility. And then just on a personal note, when she's not at the lab bench or recording Unbiased Science, Sarah does all kinds of things like playing softball, rowing crew, kickboxing, and is an avid reader and board game enthusiast. All right, Sarah, here we go. Thank you so much for joining me.
That's me. That's all you need to know. That's...
All right, bye, Sarah. No, I'm just joking.
Okay, see ya.
See ya.
Nice to have been here. Oh, incidentally, Chicago is the correct pronunciation of that word. There is no other way to pronounce it. It's Chicago.
Okay, so my only, and I'm so embarrassed. So no, no one actually, no one talks that way. All right, so I've just humiliated myself.
No one talks that way.
Okay, cool. Well, my only real exposure to that, well, I guess fake accent was SNL. And what is it? Like the Bears, like that whole, do you know what I'm talking about? Am I aging? But yeah, it's so funny. And I know I said this to you. As you may know, I grew up in Brooklyn, city girl, even though now I'm living my rural Western Mass life in the woods here, and I love it so much. I can't believe I've never been to Chicago. It's this other major U.S. city. I've never been there. I really don't know anything about it, so I'm coming. I'm coming your way.
Yeah. I got a guest room.
Oh, okay. Here I come. Can the kids and the dogs come? No. All right. So, Sarah, tell us a little bit about the work you're doing, the research. What does it entail? What are you assessing? And can you try, I know what you do is super technical, of course, but, so if you can help strike a balance between the technical and also just boiling down for us who aren't in your world, what it is that you do, what is it you're researching?
Sure. So I study Alzheimer's disease, which I think maybe we should start by just defining what that is. I mean, a lot of people have heard about it, but I think maybe, again, I'm a scientist, so I like to define my terms. I think that's really important. So when we say Alzheimer's disease, what we're talking about is a progressive neurodegenerative disorder. And what that means, just to break that down, is progressive, meaning that once you have a diagnosis, it is sort of like a boulder rolling down a hill. It is going to continue to get worse. Unfortunately, we have not developed any sort of therapeutic to prevent the progression or treat the disease. So unfortunately, it is also a terminal diagnosis. And neurodegenerative, what we mean by neurodegenerative is basically just the breaking down of the brain itself, essentially. The cells of the brain, the primary cells of the brain, they're called neurons. And in Alzheimer's disease and in neurodegenerative diseases in general, what happens is the neurons start to die. And that's what causes brain atrophy, which is shrinking of the brain tissue itself. And that's what causes the symptoms that we typically associate with Alzheimer's disease, like memory loss, behavioral changes, and all of the sort of like devastating symptoms that we all associate with dementia. So my research is focused on looking at both the genetic and what's called the epigenetic basis of Alzheimer's disease. And so when we talk about genes, we're talking about the raw genetic material, our DNA, the code that we are born with and that stays constant throughout our life. And when we talk about epigenetics, epigenetics literally translates to on top of genes. So what that means is the way that genes either are activated or silenced throughout the lifespan. And the activation state of various genes changes throughout our lifespan, and that's what causes the phenotypic changes that we associate with normal aging. But in Alzheimer's disease, because not all aging is pathological aging, right? Not everyone who ages is going to get dementia and Alzheimer's disease. So there's physiological aging, and then there's pathological aging. So my research is focusing on looking at that divergence and trying to see how we can identify where physiological or normal aging goes awry in an attempt to sort of prevent that from happening.
Oh my goodness, that is so incredible. Sarah, you mentioned a term that I want to talk just briefly about, epigenetics. This is something, I mean, I hear that word all the time, get lots of questions about it. In layperson terms, how would you explain what is epigenetics?
So there's the raw DNA, there's the genetic code, and that's fixed at birth. We are born with the DNA that makes up who we are. But in every cell in our body contains all 23 pairs of chromosomes that we get from our mom and our dad. But in every single cell in our body, not all of those genes are going to be expressed, right? The classic example being that like cells in the stomach produce a gene that causes the release of acids so that helps us to digest our food. The cells in our eyes do not produce acid. Like, we do not want that to happen. Like, that would be a really big problem if the cells in our eyes were producing acid. But the cells in our eyes contain the genes that could potentially produce acid, but they are silenced. So that's epigenetics, like which genes are turned on and which genes are turned off in a given cell. Mm-hmm. Very simply. And there are a couple of different mechanisms through which that occurs. And, just to mention some of what they are, there's something called DNA methylation. So basically what that is just the addition of a chemical group called the methyl group directly onto the DNA strand itself. And that typically is associated with the silencing of genes. And then there's also what are called histone modifications. So histones are basically the proteins around which those long strands of DNA are wound. I know I'm making hand gestures and this is a podcast, so no one can see them.
I'm obsessed with it. No, some people are watching this on YouTube right now. Shout out to our YouTube watchers. Please hit subscribe. No, go on, Sarah. I'm following. I love it.
Okay. So histones, right? We have a crap ton of DNA. Like, it's a lot of DNA. It's like mirrors of DNA. And so like we need a way to kind of fit all of that inside of these tiny little cells, right? So the way that happens is we have these histone proteins. Analogy that's often used is like beads on a string. People have maybe heard that before. So histones are these beads, and the string is the DNA, and they're wrapped very tightly around these histones, and that's how all of our DNA can be packaged inside the nucleus of the cell. And so there are different chemical modifications that occur on these histone proteins that also can determine whether or not the genetic material that's wound around those histones are sort of accessible or inaccessible for what's called transcription and then translation into the proteins.
If I could just hop in a time machine and have you be my bio TA, That would be awesome. No, thank you for setting the stage there.
I wasn't teaching. I love teaching.
I mean,
this is my stuff, my whole thing.
Yep. All right. So let's get into Alzheimer's. And I want to say, and maybe this is a little bit dark Jewish humor here, but I joke with my husband, Ethan, that, you know, as an Ashkenazi Jew, in my family, we don't live long enough. We're dying from other things like, unfortunately, cancer and things like that, where we don't live long enough to experience dementia. But I will say in his family, there have been several cases of, cognitive decline. I believe it's a Pick's disease. Is that I believe that's a rare form of dementia, if I'm not mistaken, that runs in his family. So while I don't have that personal experience, I'm so moved by some of the things I've heard, some of the firsthand accounts of dealing with Alzheimer's. And actually, there's something I came across that I want to read here. This was a quote by Terry Pratchett, the author. So he died at the age of 66. It was 7 years after revealing that he had a rare form of dementia. And so he wrote this powerful account of the condition to help fight the stigma of Alzheimer's. And it was first published by the Alzheimer's Society in 2008. It was then reprinted. I'll link to this in our show notes. But here's just a very brief quote, which I thought was quite powerful. Dementia in its varied forms is not like cancer. Dad saw the cancer in his pancreas as an invader, but Alzheimer's is me, unwinding, losing trust in myself, a butt of my own jokes, and on bad days capable of playing hunt the slipper by myself and losing. You can't battle it. You can't be a plucky survivor. It steals you from yourself. So I thought that was really powerful. And I really, as I said, I get so many messages from folks who are either dealing with it themselves or watching a loved one deal with it. So just really want to acknowledge that it sounds like it's really a brutal experience.
It is. I mean, that's what makes this so devastating, is because, I mean, it attacks the part of your brain called the hippocampus and also the cortex. And these two parts of the brain are sort of what make you. Like, they define who you are. If you have, for example, cancer in the pancreas or even cancer in the blood, you still fundamentally are who you are. You have your personality, you have, all of your memories that make up who you are. But Alzheimer's and dementia in general, more broadly, is, it like Terry said, it steals you from yourself. And that's what makes it so tragic, I think. So
let's share some statistics about the prevalence, some of the demographics that are typically affected by Alzheimer's. And please jump in. And I just want to again underscore, this is not my area of expertise. So I'm looking at the data, the literature, but Sarah's really in this research. So Sarah, again, jump in if I'm...
Well, but you are a statistician though. So maybe the stats are your area of expertise. So.
All right. I'll take it. All right. So Alzheimer's disease is the most common form of dementia. It accounts for about 60 to 80% of cases. As we've alluded to, there is certainly an age-related risk. So the risk of developing Alzheimer's doubles every 5 years after the age of 65. There are other impacts. If you look at the economic impact of this disease, in 2021, the cost of caring for individuals with Alzheimer's and other dementias in the U.S. was estimated at $321 billion, that's billion with a B, dollars. And the cost for years following is the data have not been updated, but it's certainly going to be higher than that number. So that number is climbing. In terms of prevalence among older adults, we're looking at about 1 in 9 people age 65 and older, so about 11% prevalence in adults over the age of 65. It's estimated that 6.7 million Americans over the age of 65 are currently living with Alzheimer's, and 1 in 3 seniors dies with Alzheimer's or another dementia. Now, when we look at older age groups, that number, what did I say? I said about 11%, about 1 in 9 people age 65 and older has Alzheimer's. That jumps about 73% of individuals with Alzheimer's Alzheimer's are age 75 or older. In terms of gender, almost 2/3 of Americans with Alzheimer's are women. I actually did not realize that there was that gender disparity. Maybe we could just talk briefly about that. There are also racial and ethnic disparities. So older Black Americans are about twice as likely to have Alzheimer's or other dementias as compared to older whites. Older Hispanics are about 1.5 times as likely to have Alzheimer's or other dementias as older whites. There are certainly genetic factors. Definitely want to pick your brain about this. While rare early onset Alzheimer's may be caused by specific genetic mutations, you spoke briefly about this, Sarah, but in terms of actual brain changes, and I didn't realize, I know I've heard people say that the brain actually shrinks. And so, yes, so Alzheimer's can cause significant brain shrinkage. Severely affected brain can weigh about 1/3 less than a healthy brain. And I will certainly talk more about this. Lots of diagnosis challenges. So a definitive diagnosis of Alzheimer's disease actually often relies on post-mortem brain tissue examination, but there are some new diagnostic tools and biomarkers that are being explored and improving our ability to diagnose the disease with increasing accuracy during life. So, all right, Sarah, do you want to jump in anywhere in particular? Is there anything I said that you want to build out?
I do. I think it's very important to just start out. That was great. I mean, that is all 100% true. One thing that I would like to point out is the difference between Alzheimer's disease and dementia, because these two terms are often used interchangeably, and they are in fact not the same thing. So when we talk about dementia, dementia is actually a symptom of Alzheimer's disease. Dementia is the condition of memory loss and behavioral changes. And we're talking memory loss that interferes with day-to-day life. There are different types of dementias. So there are different conditions and diseases that can cause dementia, but the most common of them is Alzheimer's disease. So that's why Alzheimer's disease and dementia are often used interchangeably, but they're not the same thing, because not all dementia cases are Alzheimer's disease, but all Alzheimer's disease cases involve dementia, if that makes sense.
It does make sense, and I had no clue. Thank you for clarifying that.
So there are other types of dementias like frontal temporal dementia, Lewy body disease. These are much less common than Alzheimer's disease. So Alzheimer's disease makes up 60 to 80% of all dementia cases. So that's why there is sort of this, these terms are sort of used interchangeably. But in fact, dementia is a symptom of Alzheimer's disease, which is sort of an important point.
And then are there different types of Alzheimer's?
Okay, so as far as the actual symptomology of the disease, no, there is just one type of Alzheimer's disease. As far as the causes of Alzheimer's disease, and now we're going to get into the genetics a little bit, there are two different sort of subsets of the disease, but they are the same as far as the progression and the changes to the brain go. So the most common cause of the most common Alzheimer's disease type is what's called sporadic Alzheimer's disease. And this makes up about 99% of all Alzheimer's disease cases. So the vast majority of Alzheimer's disease cases. And this sporadic Alzheimer's disease is also referred to as late onset Alzheimer's disease. So typically we see this onset in people over the age of 65. We mentioned that the prevalence increases every 5 years beyond age 65. And that's because that's when sporadic Alzheimer's disease begins to manifest. Now, the 1% is what's called familial Alzheimer's disease or early onset Alzheimer's disease. And this is, I hope, might be a bit of cause a bit of comfort to listeners to know that this is a very small fraction of all Alzheimer's disease cases, less than 1%. But this type of Alzheimer's disease, familial Alzheimer's disease or early onset Alzheimer's disease, is caused by specific genetic mutations. And these genetic mutations occur in one of three genes: the amyloid precursor gene, the presenilin-1 gene, or the presenilin-2 gene. And there have been dozens of familial Alzheimer's disease mutations that have been identified in these three genes. And if you have one of these genetic mutations in your family, is autosomal dominant. So there's a very good chance that you will also have early onset Alzheimer's disease if it runs in your family. But again, I just want to emphasize a very small percentage of people. But this is where you have, it's the most devastating form of the disease. You have pre-age 50, the dementia symptoms start to set in, and it's incredibly sad, but it's also incredibly rare.
So, okay, can we now talk about some of the changes that occur to the brain? You know, I hear amyloid, and I think I heard you say it earlier. I mean, beta amyloid is something that comes up quite a bit in conversations. I understand there are lots of different changes that occur. So can you talk to us about some of those changes? And then I know that'll be relevant once we talk about some of the current treatments. So yeah, if you could help set the stage there, that would be great.
Yeah, absolutely. So there are three things that are required for a diagnosis of Alzheimer's disease. So we already talked about dementia, and that's, again, that's the memory changes, the memory decline, behavioral changes that we often associate with Alzheimer's disease. Then a lot of you've probably heard of amyloid or beta amyloid. And amyloid is actually a naturally occurring protein in the brain. We all have amyloid in our brains. There is nothing wrong with the actual protein itself. What happens in Alzheimer's disease is that there's a change in the structure of the protein of beta amyloid such that it becomes, let's call it sticky, and what's called aggregates. So it clumps together outside of neurons, the cells in the brain, and it interferes with the way that neurons talk to each other. And that is what sort of makes it so problematic in terms of a pathology, is when it aggregates and misfolds. So proteins fold into different conformations, and that's how they do what they do. What happens in Alzheimer's disease is that amyloid beta misfolds and clumps together into these aggregates that are also called plaques. So amyloid plaques are one of the pathological hallmarks of Alzheimer's disease. Now, the other protein is tau. And again, tau also in all of our brains, we have tau. It's actually a very important structural protein in neurons. But what happens in Alzheimer's disease is, again, this misfolding and this aggregation. But the difference with tau is actually inside of the neurons themselves, versus amyloid plaques are outside of neurons. Tau is inside the neuron itself. So what happens is we've got sort of a double whammy in Alzheimer's disease. We've got these misfolded proteins that are attacking the neuron from within, and then we've also got these clumps of misfolded proteins outside of neurons that are interfering with the way that the neurons talk to each other and communicate.
That was so beautifully said. And it's interesting that you use the word sticky. I feel like that's when you were describing the beta amyloid, right? I think that's when you used it in that context.
Yeah.
That's a word, like I've heard that phrase quite a bit. Can you just, one more time, I'm sorry, just help me understand what you mean by sticky?
Okay, I actually have an analogy.
Oh, love.
I love an analogy for explaining complex biological processes.
Yeah.
Okay, so let's try this out. I actually was just mulling this over the other day, and I don't know if it's actually going to work, but let's go for it. Okay, so think of amyloid, just the regular normal amyloid that we have in all of our brains, as like tiny little gumballs. So gumballs themselves, like non-chewed, just normal gumballs, like they're not going to stick together. They're just rolling around in the brain, doing their thing. They're just, normal gumballs. But if you chew them, right, they're going to change in structure, and they're going to become sticky, and they're going to clump together.
Loving this analogy.
Think of normal amyloid as just gumballs, like the type you see in gumball machines, if they still have gumball machines. I don't know.
Oh yeah, I have one.
But just in ball form, that they're just like rolling around, but they're not going to stick together because they're not chewed. They're just going to roll around. You could stick your hand in a bowl and pick one out if you want to. They're not sticky, but they experience a conformational change. They're chewed, then they become sticky, and they're going to clump together. And that's what happens with amyloid. So it becomes, something changes to the protein itself, and it becomes sticky, and then it's just going to clump all together like sticky bubble gum.
Okay, I love that analogy. That helps so much. And you're proud of that analogy, and you should be proud of that analogy. I see you grinning over there. I love it. All right, so this is great, and I want to put it.
You have to understand, like, not all of my analogies land.
Well, this landed. 10 out of 10.
Good.
Love it. All right. So I want to put a pin in this because I think, and you can correct me if I'm mistaken, this is very relevant to, some of the treatments that are being explored for Alzheimer's. But before we get to treatments, I want to just talk a little bit more about risk factors, and acknowledging that there are some risk factors, and this goes for all things, not just Alzheimer's, that are modifiable and some that are non-modifiable or fixed. So there are certain things like age or race or things like that, genetics, that we can't.
Sex.
Right, exactly. Sex that we cannot modify. But then there are behaviors like smoking, drinking, other things that, of course, we can. So when it comes to Alzheimer's, can we just talk a little bit about the risk factors? Are there any that are modifiable? I know we've already covered age, how the risk doubles every 5 years after the age of 65. Obviously, even though we may want to, we cannot slow down the aging process. Sex, as you said, we discussed how 2/3 of all Alzheimer's patients are women. But let's talk about some of the other things. So what about lifestyle? Any other things that you can share with us?
Sure. I would just like to just start with a genetic risk factor, because it's something that maybe some of the listeners have heard of. The primary genetic risk factor for Alzheimer's disease, and this is, I just have to emphasize, a risk factor, it is not causative, is a gene that is called ApoE4. So ApoE stands for apolipoprotein type E. And basically, apolipoprotein type E is just a protein that transports cholesterol in the brain. So it's very important because cholesterol is really important for the health of neurons, and ApoE just transports cholesterol in the brain. It's also present in the periphery, but we're talking about the brain today. So ApoE has 3 different alleles. So an allele is just the copy, the subtype of a gene that you inherit from both of your parents. And the allele that is associated with an increased risk of Alzheimer's disease is the ApoE4 allele. So there's also ApoE2 and ApoE3. ApoE3 is the most common genetic allele in the population, so most of us are ApoE3, and it is the risk factor null gene. It is not associated with any kind of risk factor for Alzheimer's disease. ApoE4 is, for some reason, we in the research community haven't yet identified exactly why. There are a lot of hypotheses out there, but this gene is associated with an up to 13 times more or 13-fold greater risk of developing Alzheimer's disease as compared to ApoE3. And just to give another way of framing this, the prevalence of Alzheimer's, of ApoE4 in the overall population is less than 10%. But Alzheimer's disease patients, 40% of all Alzheimer's disease patients have at least one allele of ApoE4. So there's really something going on here with ApoE4. And it is the greatest known genetic risk factor for Alzheimer's disease.
So I have a question. I've spoken in the past, going sort of off topic here, but I have a lump that was found in my breast. And so I had to go through all kinds of, screenings and I was referred for genetic testing. They were, of course, looking for the BRCA gene, just to determine my risk, since that's a known risk factor for the development of breast cancer and other cancers. Anyway, and it turned out I don't have those genetic markers. I'm probably saying everything incorrectly, so don't judge me. I'm not a geneticist. But is this the type of thing, these ApoE genes that you're describing, are people getting genetic tests for these things? I guess they're not. Okay. Can you talk about that a little bit?
Okay. So, of course, anyone can request a genetic test for anything. You can do whatever you want. But it's really not beneficial to go and ask for a genetic test for this gene.
Got it.
First of all, as I mentioned, it is not deterministic, meaning that if you have an if you carry this allele, if you have ApoE4, it does not mean that you're 100% going to get Alzheimer's disease. Quite the contrary. There's no way of determining whether or not you will get it. So if you go and get a test for this gene, and this is why this is not something that is standard in clinical practice. It's not standard in clinical practice because there's no reason for it.
Right. And that makes total sense. And just to clarify, the reason I was sent for genetic testing is we may have taken different action if I did test positive. That would have impacted my risk. I may have gone for mastectomy. There are all kinds of things that I could have done with that information.
Right.
So a very different story. And by the way, this is a good reminder.
Absolutely.
Sarah, I have to schedule my mammogram. If you could remind me after we drop on. I keep forgetting to schedule that, but all right. So let's get back to this. So, all right, modifiable risk factors. So, all right. So you were talking about genetic. What about lifestyle factors?
Sure. Yeah. So this is one thing that I get asked a lot as an Alzheimer's disease researcher. Two things people say when I tell people what I do for a living. There's just two things. First thing is they've got to tell me about a relative that they have that has Alzheimer's disease, or that they know of that has Alzheimer's disease. Which is just to say, and I don't mind listening. I don't mind hearing that. It just is to say just how prevalent this disease is that virtually everyone that I tell that I am an Alzheimer's disease researcher, they're going to tell me, oh, I had an uncle, I had a cousin, my grandparents, virtually everyone is affected by this disease. It's horribly prevalent. So that's one. And then two is they want to know, what can I do to prevent this from happening? My favorite thing to say is that what is good for your general health, your overall well-being, is also good for your brain health. So you're going to go to the primary care physician and they're going to tell you, don't smoke, don't drink to excess, make sure you're exercising and staying active, make sure you're eating a healthy, balanced diet, make sure you are managing your cholesterol, your blood pressure, your vascular health, and just all of these things that we know are good for our overall health and well-being are also going to be good for your brain health. And it's going to help to sort of keep us cognitively sound and intact into late in life. There's no magic bullet.
I often see things like, we'll do daily crossword puzzles, use your brain. You can exercise your brain. Is that a thing?
Okay, actually, yes. That is another thing that I was going to mention. And that's the thing, that is what's called building up your cognitive reserve. And all of what that means is, there's this concept when it comes to learning languages, use it or lose it. And that's also kind of what's happening in the brain too. I really hate when people call the brain a muscle, because it is not a muscle. And they're like, oh, you just exercise your brain.
Right.
It's not a muscle. Just please, it's not but it is, we have these connections between the cells in our brain, these neurons, and the way that you strengthen the connections between neurons is to use those pathways. And so doing things that that keep you sort of cognitively active. Like crosswords are great. Reading is amazing. I'm a huge proponent of reading, but also things that, like learning. Learning is amazing for your brain. And, I think like even after you're done with school, like one of the reasons I love being a scientist is because I am a lifelong learner. Like I keep learning, and it's like one of my favorite things about the job. And that's something that has been shown to actually be associated with a lower risk of developing Alzheimer's disease is higher levels of education. And it doesn't have to be formal education either. I mean, you can learn things informally, like on your own. So that's a big thing. Also staying socially active too. Like that is a big thing that has been shown to be associated with a slower decline in cognitive capabilities. It's been shown that people who are very successful cognitive agers have very rich social lives. And they have a lot of they have communities, they have support systems, and they have they have a lot of friends, and they're communicating all the time. So like that's another thing that is really beneficial with regards to staving off of dementia and pathological aging too.
So just a note to listeners, this is for sure going to be a longer episode. We're already at 40 minutes and we haven't even gotten to treatments. I hope you're cool with that. I love it. I mean, I'm learning so much here, but so let's keep going. That was just a heads up. Okay. So let's talk about some of the treatments. So can you walk us through what is available? I mean, I know there's been some, I even just did a post recently. I was just trying to dig it up on my phone, but I couldn't find it quickly enough. Some controversies around some treatments, some new treatments that are really like showing some promise. Let's talk about them. Can you set the stage here?
Yeah, absolutely. So I am just going to, I know probably what you're referring to is the monoclonal antibodies against amyloid beta.
Yes.
But before we get to that, I just want to mention like a couple of other classes of treatments, because the monoclonal antibodies are relatively new. They have not, they've only just been in 2021 was when the first one dropped. So before that, there were two other classes of pharmaceuticals that were used to treat Alzheimer's disease. And again, no way to actually, there's no way to actually treat it. It's really just symptom relief. And these classes are, so the first one is what are called cholinesterase inhibitors. And these are, galantamine, rivastigmine, donazepam. I don't know. I don't know how to pronounce them.
Well, because you're reading them, right? You're not. I always say, right? You're reading them. You're not saying them.
And also, I'm not a clinician, so like I know they're cholinesterase inhibitors. That's all I need to know, right, is that that's the mechanism of action. And then like my father, who's a physician, will try and talk about pharmaceuticals together, and I'll we'll be talking about like a class of pharmaceuticals, and like I'll know the actual chemical name for it, and then he'll know the pharmaceutical name for it, and we'll be talking about the same thing, but we're not actually talking about the same language.
Shout out to Murray. All right, Sarah. So okay,
okay, I'm sorry. That was a bit of a tangent. Yep. Anyway, cholinesterase inhibitors. Cholinesterase inhibitors. These drugs work by increasing the availability of a neurotransmitter that's called acetylcholine. And what happens in Alzheimer's disease is that, as I mentioned, like way at the beginning of this episode, is that the neurons die. So what happens is the neurons that produce acetylcholine, they're dying off. So there's less acetylcholine that's available for the neurons that aren't dead to use to communicate with one another. So all the cholinesterase inhibitors do is that they prevent the breakdown of the available acetylcholine and allow the neurons that are still active to have more access to that neurotransmitter, essentially. So that's cholinesterase inhibitors. There is another drug that's used, and cholinesterase inhibitors are more effective in the early stages of the disease. Okay. In the more advanced stages of the disease, there's a drug called memantine, and that is what's called an NMDA antagonist. But paradoxically, what happens in Alzheimer's disease is I did mention that there is cell death. But also what's the case is that the existing neurons sometimes what happens is they become excitotoxic. And what that means is they just become a little bit too happy. Like they fire a little bit too quickly. They're trying to compensate by the fact that their buddies are dead. They're not available anymore. So the synaptic connections that are available sort of become hyperactive. So this can cause a whole slew of other problems. Very similar to underactive neurons, actually. And what this drug does, memantine, is it just sort of calms down the neurons a little bit and prevents this excitotoxicity from happening. So that is memantine. And memantine works on a different neurotransmitter called glutamate. So we have the cholinesterase inhibitors, and these are working on the neurotransmitter acetylcholine. We have the memantine, and there are other NMDA antagonists as well, but that's just the most common one. That's working on glutamate. Now we can get to the monoclonal antibodies for amyloid beta. And this is probably what everyone's just wondering about too. But I just thought it would be remiss.
Leqembi, right? There's a lot of. Sorry, yes. Get into it.
Right. So, and again, I know the actual chemical names for them. But yeah, I was actually just at the Alzheimer's Association International Conference. I just got back. This was in Philadelphia this year, and there were all of the pharmaceutical companies that are producing these drugs. They were all there, and so yeah, Leqembi, Aduhelm, Kisunla are the names.
Bless you.
So stupid. Dude.
That tickled her. I'm sorry.
No, I love it. That was so dumb.
All right. So how do these monoclonal antibodies work?
All right. So basically, what these drugs do is, I mentioned this, the misfolded protein, these like sticky bubblegum clumps of amyloid beta. There is a type of cell in the brain, not neurons. So neurons, the main cell type in the brain that causes, that makes you, basically. But there's another type of cell in the brain called microglia. And microglia are the resident immune cells of the brain. And basically, how I like to think of microglia is they are the garbage trucks of the cell. Of the brain, the garbage trucks of the brain. So they go around and they collect all of the crap in the brain that shouldn't be there. And they clean up the streets, and they make it so that the neurons can have clean pathways to talk to one another. And what these drugs do, these monoclonal antibodies against amyloid beta, is they sort of tag the clumps of amyloid beta, like put just like a little flag on them so that the microglia can access the clumps a little more quickly and sort of, engulf them and clear away that sticky gum from between the cells so they are able to communicate and talk to each other a little more easily.
Love it. Take a breath. That was incredible. Got it.
Yeah, that's a lot.
So, I mean, why are we hearing so much now about these monoclonal antibody treatments? Is there controversy? Are they showing promise? Are we like overstating their benefit? Like why are these drugs on the radar right now?
Okay. It's a good question. Because the other drugs that I mentioned, they do not address the root cause of Alzheimer's disease, right? So the three things that I mentioned that make up Alzheimer's disease, right? Dementia, amyloid plaques, and neurofibrillary tau tangles, those three things. Cholinesterase inhibitors and memantine, the NMDA antagonists, like they don't really address the root cause. What's so cool about these monoclonal antibodies against amyloid beta is that they are actually addressing one of the root cause. They are going to the source. They are attacking that amyloid beta that we know is interfering with the way that neurons function and is causing them to die over the course of the disease. And that's why this is so exciting, is because it's really not even, it's more of a step towards addressing the root cause as opposed to just like the symptoms.
So are you, and we didn't prepare, to get too into the weeds on like efficacy data, but like, are you impressed by the data that you're seeing for these drugs? Or, I mean, it sounds like there's nothing that is like, we have a cure for Alzheimer's, like, right? There's nothing like that, but they're showing promise.
Yeah, it's definitely not a cure. That cannot be overstated. It is not a cure. We do not have a cure for Alzheimer's disease. And the reason for that is because we don't know what exactly causes Alzheimer's disease even. And that's something that basic scientists like myself are trying to determine. But in the meantime, we have these pharmaceuticals that are available that can slow the progression of the disease. So it's not going to stop that boulder from rolling down the hill, but it is going to make it roll a little bit slower. And I will admit that back in 2021, when the very first monoclonal antibody came out, it was called aducanumab. Well, that's the scientific name. I don't really remember what the actual name was. When the very first one came out, there was a lot of controversy in the FDA with regards to the efficacy of it, meaning that the drug was very successful in clearing amyloid beta from the brain, right? There are brain scans, very advanced brain scans that we can do now so that we can track the clearance of amyloid beta following administration of this treatment. So there was no doubt that this drug was very successful in clearing amyloid beta out of the brain. The question was there a corresponding change in the clinical manifestation or the symptoms? And that's where the controversy lied, or that's where the controversy was, basically, is that there were a lot of clinicians and scientists that didn't believe that there was convincing enough data to suggest that there was a corresponding improvement or slower decline in in memory capabilities and cognition.
That is so interesting. Yeah. So you're saying like it showed like from the brain imaging, although those data were promising, but in terms of clinical translation into, how this manifested clinically and in the real world, we weren't necessarily seeing it translate there.
Correct.
Real improvements
Correct.
there.
Yeah. And that's the thing, is that like you could see all the changes in the brain you want, but at the end of the day, if you're not seeing a change in the clinical manifestation and you're not seeing that actually, the decline in memory is really slowing down in these patients, then like, what is the point?
Right. All right, Sarah, any last thoughts on treatments before we get into our segment, which I'm super excited about, to maybe start, closing out the episode? Any other thoughts on treatments?
I will just say,
or you feel like
I will just say back one more thing about the monoclonal antibodies. So that was in 2021 when the first one came out. There are new ones out now. It's 2024. A lot can happen in science in just a few years. I mean, it doesn't sound like that's a lot of time that's passed, but really a lot has changed. And the newer drugs, the newest one that was just approved actually like a month ago or a couple months ago, donanemab, that one has some more promising clinical data that pretty much everyone agrees for the most part is actually efficacious. So I just wanted to point that out.
No, that thank you. That's a nice optimistic note to end the therapeutic conversation on. Not all doom and gloom. All right. Well, folks, I don't know if you're as excited as I am, but we are bringing back a segment here that is one of my very favorites, the Heard from the Herd segment. And what this is I'll put question boxes on our social media page at Unbiased iPod, on Instagram, on Facebook, on all the social media channels where folks can submit questions about a specific topic. So I put a question box out. I said, what questions do you have about Alzheimer's disease? And oh my goodness, did we get a bunch of responses. So Sarah, if I may, can we do a little bit of like a speed dating round robin Heard from the Herd segment here where I ask you questions and you answer them?
Yes, let's do it. 100%.
All right.
Heard from the Herd.
question one. Thank you. I appreciate that. Our listeners probably appreciate that, but this is going to be fun. So, all right. Alzheimer's, this is a question that was received. Alzheimer's runs in my family. Is it genetic? How can I prevent it?
Right. So this goes back to the two different types of Alzheimer's disease. Most likely, if it runs in your family, it does not mean that you're for sure going to get it. So don't automatically jump to the conclusions. Dementia is not an inevitable part of aging. Even if someone in your family has it, it doesn't necessarily mean that you are going to get it. Also, not all ApoE4 carriers will develop Alzheimer's disease, so don't go get tested for that. I wouldn't recommend it anyway. Just lead a healthy lifestyle, eat healthy, exercise, keep your blood pressure under control, don't smoke, don't drink to excess, stay cognitively active, all that good stuff.
All right, next, and we did already address this, but maybe just like a quick summary. So what can I do to prevent Alzheimer's?
Basically, anything that's good for your overall health is going to be good for your brain health. So just lead a healthy lifestyle. Make sure you're socially active. Get some of that intellectual stimulation. Read a book every once in a while. Get off social media for like 5 minutes. And, I'm not saying 100% you'll be able to prevent Alzheimer's disease, but there's a good chance that you will decrease your risk.
All right. I just realized we have a lot of questions. So let me sort through here and go to the ones that I don't think we addressed. So, okay. How can we differentiate between normal aging and forgetfulness from Alzheimer's?
This is a good one, and one that I get all the time. So people are always saying like, oh, I forgot my keys, or I forgot where I parked my car. Like, I have Alzheimer's disease. Like, no, you do not. Like, don't worry about it. Everyone forgets things. Everyone, is going to forget where they parked their car, forget where they put their keys, or walk into a room and forget why they went into that room. There is a very distinct difference between forgetting where you put your keys and forgetting what keys do altogether. So that's really, I think, the most the most telling example of what it means for the dementia versus just natural forgetfulness. I mean, dementia is really like it's interfering with the way you're living your life and the way you are functioning.
All right. Now, this question, I mean, there are so many sub-questions, but broadly, are there links to diet and Alzheimer's? And I will say before you go on, I'm sitting here, I'm actually eating blueberries as I often do for breakfast with yogurt or oatmeal. I don't know. There's a lot going on TikTok about, eating a handful of blueberries every morning will prevent your risk of, will reduce your risk of Alzheimer's. There's also a lot out there about the Mediterranean diet. I sometimes get yelled at for using that term. So just to be clear, I'm talking about a diet that really emphasizes fruit, veggies, whole grains, legumes, fish, seafood, and low amounts of red meat, eggs, and sweets. You may call that something different, but it is at least colloquially referred to as the Mediterranean diet. Can you talk to us about diet and Alzheimer's?
Yeah, absolutely. So I don't really know what the problem is with Mediterranean diet, but essentially all of what that means is just a diet that emphasizes fruits, vegetables, whole grains, legumes, fish, seafood, and just like lower amounts of stuff like red meat, eggs, and sweets. But pretty much anything in moderation. And I'm not a nutritionist or a dietitian, but there is no food that like we have definitively said, oh yeah, like if you eat that, then you'll get Alzheimer's disease for sure. Like there's no such thing as that. And sort of on the flip side, there's also no food that for sure we've identified, like if you eat that, you'll for sure not get Alzheimer's disease. Like there is no magic bullet with regard to diet or any kind of supplementation that we know is going to just be all end all with regards to preventing Alzheimer's disease.
Well, and on that note, I mean, a couple of things there. Eating blueberries, for example, that's a good thing, right? There's lots of nutritious elements to blueberries. So if you like blueberries, eat blueberries. But you shouldn't eat. If you don't like blueberries, yeah, exactly. But don't force yourself to eat blueberries if just solely on the basis of preventing Alzheimer's.
Yeah, please don't.
And I think with so many things, we say the dose makes the poison. The dose also makes the benefit. So while there may be, and I don't know if there's a particular chemical something in blueberries that makes them there's something that has some association or, protective effect against Alzheimer's, but I would think it's unlikely that in the dosage that we get, like having a handful of blueberries in the morning is going to have a real clinical or therapeutic effect. So just something to keep in mind there. All right, Sarah, we are holy moly, we're over an hour. So let me just go quickly. So just real quick, are there any supplements or vitamins to either prevent or cure Alzheimer's that you recommend?
Nope, just not at all. That's quick answer to that. We can move on.
Love it. Yeah. And just some of the things I hear, like lion's mane, ginseng, curcumin, turmeric. Again, as Sarah just said, no evidence showing any preventative or curative effect or association with Alzheimer's. All right. What about diagnosis? I guess I've looked into it too. I
mean, like I am not one of those scientists that's going to just dismiss something offhand because it just sounds like it's bad. Like someone told me recently, someone asked me about lion's mane recently. I didn't know that I didn't even know what it was, but they were like, does that prevent Alzheimer's disease? Just a friend of mine. And I was like, I've never heard of it, but just because I, as an Alzheimer's disease researcher who has been doing this for over half of a decade, hasn't heard of it, doesn't mean it's not a thing. So I went and I looked into it, but really no convincing evidence, none at all. And in those types of studies, like the blueberry studies, a lot of them were funded by companies that farm blueberries. And the lion's mane studies,
big blueberry,
like big blueberry. But also the lion's mane study was funded by a company that sells mushrooms. So it's just these things that we gotta take with a grain of salt. So I have looked into this stuff, and I'm not convinced.
All right, Sarah, 2 more questions, and then we're going to close out what I'm really confident is a great episode. So I'm so excited. But okay, so one, just super briefly, how do we diagnose Alzheimer's? Is there a test for it?
Oh, I don't even know if we're going to have time for this one. Essentially, how to diagnose Alzheimer's disease. It used to be that you couldn't diagnose it until after death or postmortem. But now we have some really high-tech new brain scanning technologies that allow us to look at the levels of amyloid and tau in the brain. So those brain scans in conjunction with neuropsychological testing. And these types of tests are done by a trained professional neuropsychologists, and they're very extensive, multiple hours long evaluations. And that type of testing in conjunction with these brain scans can pretty much definitively say whether or not someone has Alzheimer's disease.
Beautiful summary of something I know is far more complex than that. So thank you for that.
Well, there are blood tests, but we're not going to, let's not touch that one yet. Like that's...
Okay, future episode. Yeah. All right. And finally, Sarah, someone asked, I know the brain is losing white matter / dying. Can the patient feel that?
No. Short answer being no. There are no pain receptors in the brain. And so you actually won't be able to physically feel the synapses, the loss of synapses and the brain cells dying. You won't be able to feel that. Another thing that is the case is that oftentimes dementia patients don't realize what is happening to them once the disease has progressed, has reached a point of like very, very far progression. So maybe in the earlier stages, like when we read that Terry Pratchett quote at the beginning of the episode, a lot of patients maybe will notice the changes in their behavior. But once the disease has progressed very far, they won't necessarily know what is happening, or that they won't recognize that they have Alzheimer's disease or dementia. And that's why the diagnosis is often a lot harder on family members and caregivers than the patient itself. Right. Because like unlike other terminal diagnoses like cancer, the patient isn't always aware of what's happening.
All right. Well, Dr. Sarah Scheinman, I cannot thank you enough for your time, for your expertise, for your chutzpah. I'm sure it's quite evident to the listeners, why I've totally fallen in love with you and why I'm so excited to have you join me on the pod and lend your expertise in biological science. So thank you so much, Sarah. I also want to give a shout out, while I am often the face of Unbiased Science, I just want to shout out my amazing team working in the background. I'm going to do some spotlights on individuals coming up soon, but they're in the background helping me do literature searches, really combing through the evidence. Of course, I have an amazing team helping me with infographic development, graphic design. So shout out to my amazing team. I also want to give a shout out to Jared Breitup, who's my executive producer, to Ben Siegel, who is our sound editor, and to our new team member, Sarah Lemieux. I hope I'm saying your last name correctly, Sarah, who is a brilliant sound editor and soundscape artist, which is a new term for me. But Sarah's going to really up our production value. So thanks so much to my amazing team. Thank you to our listeners. Certainly hope you learned a thing or two on today's episode. If you aren't already, please be sure to follow Unbiased Science on social media at Unbiased SciPod on Instagram, Facebook, Twitter, X, Y, Z, all the things. Follow us everywhere. We also have a Substack, which is our weekly newsletter, and you can subscribe to that. It is free, although there is a paid option if you're able and willing to provide financial support for our science communication efforts. You can subscribe at theunbiasedscipod.substack.com. Remember, we have a searchable database that's, oh my God, so many addresses here. Unbiased. Wait, hold on. Oh, it's uspodsources.com. You can search by keyword. Again, thank you so much. And finally, the last thing that you could do is leave us a review on Apple, on Spotify, wherever it is that you're listening to this. Give us a follow on YouTube. It really helps because obviously the whole goal of this is to have an impact and to share science with folks. Thank you for tuning in for No Nonsense, Just Science.
The sun's shining, birds are singing, and all feels right in the world.
Until the season changes, and suddenly you lose your motivation to get out of bed. In fact, 1 in 5 people experience some form of depression, no matter the season or time of year.
At the American Psychiatric Association Foundation, our vision is to build a mentally healthy nation for all, because we want you to live your best life and be your best you all year round.
Please visit mentallyhealthynation.org to learn more.